This is General Chemistry, covering the topic of gas, Part 4. Previously, we learned about ideal gas law, which is an attempt to form relationship between physical properties of gas. And now we will try to apply this PV equal to nRT into different situations. Here, we will try to use ideal gas law to figure out molecular weight and gas density. Please be mindful that the terms molecular weight, molecular mass, and molar mass are sometimes used interchangeably, but as long as you stick with the unit gram per mole, you should be good to go. Let's take a look first at the formula PV equal to nRT. The term N there, which is mole, are associated with the molecular weight. We knew that N equal to little m over big M, or mass over molecular weight, which means PV will be equal to little mRT over big M, and molecular weight gonna be equal to little mRT over PV. So now we know how to figure out molecular weight from the ideal gas law. But how about the density? The density, or D, equal to mass per volume, which means density can be equal to PM over RT. Now we know how to figure out gas density from the ideal gas law too. Even though these two new formulas are pretty useful, I would not recommend you to memorize them. The only formula PV equal to nRT. The rest of them you can derive easily in seconds. So let's take a look at some practice questions here. For this one, an ideal gas sample weighing 20 grams occupies 15 liters and exerts a pressure of 8 atm at 25 degrees Celsius. What is the molecular weight in gram per mole of this gas? It's an ideal gas, so most likely we will be using PV equal to nRT. And we know that PV equal to little m over big M, which comes from mole, RT. And since they're looking for molecular weight, we can get molecular weight equal to mRT over PV. So you can see that you need to memorize only PV equal to nRT. The rest of them you can derive really quickly. So little m is 20 grams and R is 0.082 liter atm per mole Kelvin, and T is 298 Kelvin, and that should be over P, which is 8 atm, and V, which is 15 liter. Alright, so 8 here should be approximately 0.01 there, and then 15, that should be 3, that should be 4, and 298 here I would approximate to be 300, and now we can get 100 there. So that simplified the calculation quite a bit if you can approximate it, and that should be about 4 gram per mole, and that's the answer. And if you actually have calculator, you can plug it in and you should get about 4.07, yes, gram per mole. They're pretty close anyway. Alright, in these questions, an unknown gas sample weighing 380 grams occupies 19 liters and exerts a pressure of 11 atm at 23 degrees Celsius. Which of the following could possibly be the unknown gas? A. Acetylene, B. Boron trifluoride, C. Carbon dioxide, D. Xenon. So this question actually a little bit similar to the last one, but they go a little bit further. They ask about the identity of the unknown gas. Alright, so we should be able to use PV equal to nRT again. And N equal to M over big M. And PV equal to M over big M RT. Of course, the molecular weight gonna be equal to MRT over PV. Alright, so as long as you can find molecular weight here, and then you can go up there in A, B, C, D multiple choice and see which one match, and that's the answer. Alright, so let's try. So M equal to 380 grams. R is 0.082 liter atm per mole Kelvin. And T here is 296 Kelvin. And then P here is 11 atm. And V is 19 liter. Alright, so let's try figure it out. 19 and 380, that should be 20. 11 and 296, that should be approximately 2 and then 7 there. Alright, so now they simplified quite a bit. We can just multiply everything through. That should be 0.082 is about 0.08. So that should be 2 here and then there, right? 43.2 gram per mole. Alright, so we got this. And now we have to go back up there to figure out the molecular weight of each of them. So let's try acetylene first. For acetylene, C2H2 is 24 plus 2, gonna be equal to 26. Boron trifluoride is about 11 plus 57, yes, that should be 68. And then carbon dioxide, that should be 12 plus 32, gonna give us 44. And then xenon is 131. Alright, so the one that closest to 43.2 gram per mole is carbon dioxide. The answer is C, which gives us 44 gram per mole. And if you actually use calculator in this calculation, you should get the value to be about 44.1 gram per mole. Again, it's pretty close to the approximated value that we got up there, 43.2 and 44.1. So let's try another question then. For this one, determine the density in gram per liter of nitric oxide gas at 20 degrees Celsius and 1 atm. Okay, now they're asking about density, but we can still use PV equal to nRT. Alright, again, this is the only formula in ideal gas law that you should remember or memorize. The rest you can derive them pretty quickly. Alright, and you know that N equal to little m over big M. So PV equal to mRT over big M. And since they're looking for the density, and density is actually mass per volume, so we can get m over v to be equal to pm over rt. Alright, and this m over v here is the d, which is density. Alright, so let's try. P here is 1 atm, and m is molecular weight. Alright, we have to figure that out. Nitric oxide is NO, so the molecular weight is 14 plus 16, and it's gonna be equal to 30, and the unit we're gonna be using is gram per mole. Alright, so we plug in 30 gram per mole over here, and then it divided by 0.082 liter atm per mole Kelvin, and T is 293 Kelvin. Okay, so you should be able to get 1.25 gram per liter here, and just make sure that the unit is actually correct. Alright, so we can try atm crossing with the atm, mole crossing out mole, Kelvin crossing out Kelvin, so we left with gram per liter, so we are correct. So that is the answer, 1.25 gram per liter. Alright, I think we are good now.